Good day. As you follow me, you will surely ace your maths test and examination. Today we are going to continue from where we stopped. Limit. Lim x approaches to of x squared minus 3. This is a simple limit equation and it can be solved by direct substitution. As x approaches 2 means that we are going to substitute 2 into this expression. That is 2 squared minus 3. 2 squared is equal to 4, right? Minus 3. 4 minus 3 is equal to 1. Is your answer. Lim x approaches minus 1 of the expression x squared plus 6. We are going to solve this by direct substitution, substituting minus 1 into this expression. We have minus 1 all squared plus 6. Minus 1 squared is equal to 1 plus 6. 1 plus 6 is 7. Then I believe you can solve this because this is a very simple limit equation. We're going to solve this by direct substitution, substituting 3 into this expression. We have 3 all cubed plus 3 over 3 squared. This gives us 3 cubed is 27 plus 3 over 9. 27 plus 3 is 30. Hence we have 30 over 9. Dividing through by 3, 3 into 30 is 10, 3 into 9 is 3. Hence our final answer is 10 over 3. I hope this is clear. Please do well to like, subscribe, follow, repost this video, and type "I want more" if you are enjoying this. Catch you. We have lim x approaches to of the expression x squared minus 4 over x minus 2. This is simple to solve. Let's solve this by direct substitution. From direct substitution, we have substituting 2 into this expression. We have 2 squared minus 4, right? All over 2 minus 2, right? Hence we have 2 squared is 4 minus 4 over 2 minus 2, right? 4 minus 4 is 0 and 2 minus 2 is 0. Hence this our answer is 0 by 0, which is indeterminate. This is indeterminate. Hence we have not gotten the solution to this limit equation. Now, since our answer is indeterminate, we must devise another means of solving this question. We're going to apply the L'Hopital's rule. In other words, the L'Hopital's rule is used to solve the limit equation whenever you get an indeterminate answer, 0 over 0 or infinity over infinity, after applying direct substitution. Now, what does the L'Hopital's rule state? The L'Hopital's rule states that we are going to differentiate the numerator separately and differentiate the denominator separately. We differentiate each term of the numerator, differentiate each term of the denominator. You won't apply the quotient rule of differentiation. No, we differentiate term-wise of the numerator, also differentiate term-wise from the denominator. Okay, now let's apply L'Hopital's rule in solving this. So I have lim x approaches 2. Now, differentiating x squared. I hope you know how to differentiate. Let me give you this preamble. I have y is equal to ax exponent n. dy dx, that is, we are differentiating y with respect to x. dy over dx, or they can say y prime, is the same as y over dx. So we are going to differentiate y with respect to x. So dy over dx is what? We will take the rule is that we will take the power and multiply the whole term here. That is, the power is n, right? So n times ax exponent n. Now we now subtract 1 from the power, so minus 1. This is the rule of differentiation. So let's apply the rule here. I have x squared, right? So I'm going to have 2 times x squared. So 2 times x squared, then minus 1. This has to differentiate. Now, minus 4. This term doesn't have x. We are differentiating with respect to x. Minus 4 doesn't have x. So if you differentiate minus 4 with respect to x, your answer is what? 0. So minus 0 all over. Now, the power of x here is 1. So 1 times x is the same as what? X. Then the power here 1 minus 1. Minus, if you differentiate minus 2 now, minus 2 doesn't have x. So when we differentiate a constant, minus 2, the answer is 0. So let's simplify. Lim x approaches 2, given of what? I have 2x, 2 minus 1 is 1, minus 0, all over. 1 minus 1 is what? 0. Now, any number or any term to the power of 0 is equal to 1. Note that. So I have, this gives me lim x approaches 2 of 2x over 1. We can now go on our direct substitution. We substitute 2 into this expression here. So we have 2 times 2, hence our answer is equal to what? 4. This is the solution of this limit question. So long we have an indeterminate solution after the first direct substitution, this will not be your final answer. No, because it's indeterminate. You must have a definite answer. You're going to look for another means of solving this limit question. You can apply L'Hopital's rule, because L'Hopital's rule is direct. You can also apply difference of two squares. Difference of two squares. So I'm going to teach you how to also apply difference of two squares to solve this same question. Please do well to like, subscribe, follow, repost this video, and type "I want more" if you are enjoying this. Thank you. Now we are going to solve this by the method of differences of two squares. Recall that x squared minus a squared can be rewritten as x minus a, x plus a. So we can write this as x squared minus 2 squared, because 4 is a perfect square. 2 times 2 is 4, hence 4 is a perfect square. All over x minus 2 as lim x approaches 2. Now, writing this in difference of two square format, we have lim x approaches 2 of x minus 2, x plus 2, all over x minus 2. We observe that x minus 2 and x minus 2 is common in the numerator and the denominator. Hence, this cancels out this. We are left with lim x approaches 2 of x plus 2. Now, solving this by direct substitution, we have putting 2 into this expression. We have 2 plus 2. Hence, our answer is equal to what? 4. I hope this is clear. Now, look at this question. Solving this limit question, first of all, we can solve this by direct substitution. Let's go by the method of direct substitution. We have direct substitution means putting minus 1 into this expression. That's the meaning of direct substitution. Substituting directly. So minus 1 all squared, right? Minus 1 over minus 1 plus 1. Minus 1 squared is 1. Minus 1 times minus 1. Minus and minus is plus. So 1 times 1 is 1. So it is plus 1. So we have what? 1 minus 1 all over minus 1 plus 1. 1 minus 1 is what? 0. And minus 1 plus 1 is 0. And this is what? Indeterminate. This is not a solution to this limit question. We're going to devise another means of solving this question. We can solve this question by two methods. One, the L'Hopital's rule, and the second method is the method of differences of two squares. Let's apply the L'Hopital's rule. From the L'Hopital's rule, we differentiate term-wise. We differentiate the numerator term-wise and the denominator term-wise. Differentiating the numerator term-wise, we have lim as x approaches minus 1. We have 2x minus 0 because minus 1 is a constant, doesn't have it x in it. By differentiating with respect to x, so minus 1 doesn't have what? X at all. So when you differentiate the term that doesn't have x is 0. Now, also, if we differentiate x, we have 1. I thought we have to differentiate x. For instance, we have x here. So let's say y is equal to x. If we find the y dx of this, the power here is 1, right? So 1 times x, 1 minus 1. And we have what? X, 1 minus 1. 1 minus 1 is 0, right? And any number to the power of 0 is equal to 1. That's how we have what? 1 here. Now, we're going to now solve this by the method of direct substitution. Put minus 1 into this expression. I'm going to have what? 2 times minus 1. And 2 times minus 1 is what? Minus 2. This is our answer by the method of L'Hopital's rule. We're going to solve the same question by using the method of differences of two squares. Please do well to like this video, subscribe, and share. Now let's use the method of differences of two squares to solve the same question. We can rewrite this as x minus 1, x plus 1, all over x plus 1. What is common? X plus 1, x plus 1 is common, hence we cancel out this. We're left with lim x approaches minus 1 of x minus 1, right? Yes. We're now going to go on the method of direct substitution. So by substituting directly, putting minus 1 into this expression in place of x, we have minus 1, right? Minus 1 is what? Minus what? 2. This is our answer. Very, very simple and straightforward. Alright, see this question. We can solve this question by factorizing. By factorizing both the numerator and denominator. A term will cancel out. But that procedure is long. It's quite long. So we can solve this by the use of the L'Hopital's rule, which is straightforward, by differentiating the numerator and the denominator. So we're going to differentiate the numerator. Differentiating the numerator, we have lim as x approaches minus, as x approaches 3 rather, 2x minus 7, right? All over 2x plus 2. Now we go on the direct substitution. Substitute 3 into this expression in place of the x's. So we have 2 times 3 minus 7 over 2 times 3 plus 2. 2 times 3 is 6 minus 7 over 2 times 3 is 6 plus 2. 6 minus 1 is 6 minus 7 is minus 1 all over 6 plus 2 is 8. And this is our final answer. Simple, straightforward, and fast. Yeah. Now look at this question. What is the answer? Let me give you time to solve it. What is your answer? Alright, let's go. Apply L'Hopital's rule, differentiate the numerator separately and the denominator separately. Differentiating term-wise, we have lim x approaches minus 2 of 2x minus 5, 2x minus 1. Now we're going to go on direct substitution. So we have 2 minus 5 all over 2 times minus 2 minus 1. 2 times minus 2 is minus 4 minus 5 all over 2 times minus 2 is minus 4 minus 1. Minus 4 minus 5 is equal to minus 9 all over minus 4 minus 1 is minus 5. Minus will cancel the minus, and hence we have our answer to be 9 over 5. Simple and straightforward. All right, see, okay, we're going to solve this question by the method of direct substitution. Direct substitution. So we have, that is, we're going to substitute 3 into all the terms having x. So we have 3 squared minus 7 times 3 plus 12 all over 3 squared plus 2 times 3 minus 15. Simplifying, we have 9 minus 21 plus 12 all over 9 plus 6 minus 15. And 9 plus 12 is 21 minus 21 all over 9 plus 6 is 15 minus 15. You observe that we have what? 0 over 0 after the method of direct substitution. When you observe that you have and your answer to be 0 over 0, which is indeterminate, that is not the actual solution of your limit question. I'm going to devise another means of solving the same problem by the use of the L'Hopital's rule or by the method of factorization. So, in order to solve this quickly, let's make use of the L'Hopital's rule. Now, applying the L'Hopital's rule, we're going to differentiate the numerator and the denominator separately. So we have ln as x approaches 3 of 2x, that is differentiating x squared. We have 2x, differentiating 7x, we have just 7, over differentiating x squared, I have 2x, differentiating plus 2x, we have just 2. I hope you know how to differentiate. If you don't know how to differentiate, just type, I don't know how to differentiate, help me. Alright, so let's continue. So substitute, we're going to now go on the method of direct substitution. You substitute 3 into this expression in place of all the x's. So we have 2 times what? 3 minus 7 all over 2 times 3 plus 2. 2 times 3 is 6 minus 7 all over 2 times 3 is 6 plus 2. So I have what? 6 minus 7 is minus 1 all over 6 plus 2 is 8. Hence, this is my final answer, which is defined. I hope it's clear. Please do well to like, subscribe, share, and comment. See you. Alright, look at this question. Lim x approaches 0 of sine x over x. Let's solve this by the method of direct substitution. That's only the first method to use. So, substituting 0 into this expression in place of all the x's, I have what? Sine 0 over 0. Sine 0 is equal to 0 and over 0, which is what? Indeterminate. This is an indeterminate solution. So this is not our answer at all. We're going to apply L'Hopital's rule. From the L'Hopital's rule, we differentiate the numerator, differentiate sine x, we have what? Cos x. When you differentiate sine x, we have cos x. When you differentiate x, you have what? 1. We now go on direct substitution. So I have the direct substitution, right? So I'll substitute 0 into this expression in place of all the what? The x's. I have cos 0 over 1. Cos 0 is equal to 1 over 1. So my final answer is equal to 1. This is the solution to this limit question. So let's take our final question before we call it a day. I'm going to solve this question. Lim x approaches infinity of lim x over x. Lim, by the method of direct substitution, as x tends to infinity, lim x, that is the method of direct substitution. Lim infinity all over what? Infinity. Alright, direct substitution. Limit infinity is equals to what? Infinity over infinity. This is indeterminate. So you're going to solve this by the use of the L'Hopital. I hope you know what the L'Hopital states. We differentiate the numerator with respect to x. So differentiating the x with respect to x, the answer is what? 1 over x. Differentiating x with respect to x, we have what? 1. So we are left with lim as x approaches infinity of 1 over x. And this expression, lim as x approaches infinity of 1 over x, is equal to what? 0. Why? Because as x tends to infinity, as x increases, 1 over x reduces. It becomes what? 0. For instance, we have 1 over 10 is equal to what? 0.1. 1 over 100, 0.01. 1 over 1000, 0.001. You see that what? As the denominator increases, the whole expression what reduces. So as 1 over x tends to infinity, the whole expression here was equals to what? 0. I hope this is clear. Please do it to like, subscribe, share, and comment. See you next time. Bye.